Hello, and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today, we'll be talking to Dr. Hoyoung Kwon about reducing greenhouse gas emissions in agriculture. Agriculture and food systems can be strong contributors to greenhouse gas emissions and, in turn, climate change. However, in the midst of this reality, there are also abundant opportunities to improve our systems, reduce emissions, and move towards a more sustainable future, so long as we can identify those opportunities first. This episode, Hoyoung discusses his work studying agricultural life cycle analyses to better identify the major inputs and outputs in ag, understand how these contribute to greenhouse gas emissions, and develop ways to improve them. Don't forget to listen to the end of the show for our student spotlight. We'll talk more about that in a minute, but before we dive in, we want to thank our sponsors, starting with Gasmet Technologies, the maker of the GT5000 Terra, the smallest portable FTIR multi-gas analyzer for greenhouse gas and environmental research. Measure carbon dioxide, methane, nitrous oxide, ammonia, and water vapor in real time simultaneously from static or automated chambers and ruminant emissions. Visit www.gasmet.com, that's Gasmet spelled G-A-S-M-E-T, or email sales@gasmet.com for more information. Our second sponsor is Meter Group. Meter specializes in robust soil moisture sensing, innovative weather monitoring, cloud data logging, advanced data visualization software, and more. Their well-published scientific instrumentation is used worldwide in universities, research and testing labs, government agencies, agriculture, and industrial applications. Listen to their new podcast, We Measure the World, to hear how innovative researchers leverage environmental data to make our world a better and more sustainable place at metergroup.com/fieldlabearth. I'm your host, Abby Morrison. Let's talk about science. Hi everyone, welcome to the show today. Today we have Dr. Hoyoung Kwon. Hoyoung is a principal environmental scientist at the Systems Assessment Center at Argonne National Laboratory. He received his master's in environmental management from Duke University and a PhD in environmental sciences from the University of Illinois at Urbana-Champaign. Before joining Argonne in 2018, he worked at the International Food Policy Research Institute in Washington, D.C., to develop analytical frameworks to promote innovative agricultural technologies in developing countries. His research at Argonne has focused on assessing the environmental impacts of biofuel feedstock production by employing Argonne's life cycle analysis model and process-based agroecosystem models. In the article published last year, he evaluated several greenhouse gas, or GHG, mitigation strategies to decarbonize the agricultural sector and linked them to the potential of lowering the carbon intensity of feedstock production for biofuels. How are you doing today, Hoyoung?
I'm pretty good. Thank you so much.
Wonderful. I'm so glad to have you on the show today. So, as was hinted at in your bio, today we are going to be talking about greenhouse gas emissions and agriculture. Importantly, how to identify the sources and then hopefully mitigate them and make them a little bit better. So, to get us started, can you just give us some background about the state of greenhouse gases in ag, kind of the good, the bad, and the ugly, with just kind of the emissions, biofuels, growing food needs, all of that?
Sure. So first of all, I want to point out that agriculture has played an important role in economic growth and development by providing food and animal feed and energy to the global population. Based on the recent estimate by the World Bank Group, the agriculture accounts for 4% of the global gross domestic product, GDP, and in some least developing countries, it can account for more than 25% of GDP. On the other hand, agriculture is energy and resource intensive. As a result, it is significantly responsible for anthropogenic GHG emissions. The worldwide is about 20 to 40% of the total GHG emissions are attributed to the food system. In the United States, according to the U.S. EPA's annual report, the agricultural sector is responsible about 11% of the U.S. total GHG emission in 2019. So there has been the increased call for transforming agriculture to achieve sustainable development goals set by the United Nations through innovative and sustainable agricultural practices. To respond to this, the agriculture and then bioeconomy community has worked to identify a list of the farming practices and technologies that can effectively reduce GHG emissions from the oil sources and the sink directly and indirectly linked to the agriculture. In our article, we evaluate the several GHG mitigation strategies that U.S. farmers can potentially and readily adopt to increase agricultural sustainability from the perspective of the life cycle analysis.
Sure. And that's a great segue because, as we mentioned, the life cycle analysis is going to be a big part of what we're talking about today. So can you give us a high-level view of life cycle analysis, kind of what that is and how it is conducted?
The life cycle analysis, the LCA, is a technique to analyze the environmental impacts and the resource use throughout a product's life, from the raw material extraction to production and extending through the product use and disposal. So life cycle analysis is being used in the marketing and regulatory program nowadays. In the life cycle analysis, the scope, including the system boundary and then level of the detail, depends on the subject and the purpose, the use of the analysis. And our study mainly focused on the farming, the life cycle analysis, LCA, which evaluate all activities related to the farm input manufacturing and crop production in terms of the energy consumption and GHG emissions. So this type of the farming LCA has been the one of the key components for the agriculture-based biofuel, the LCA.
Sure. And so when you're doing these, you're identifying all these inputs and outputs across this workflow, I guess. So what information are you looking for when you're doing these analyses? How are you weighting that information, and what, how do you identify all of the potential inputs and outputs along the timeline of that activity that you're studying?
So I will give the listener as an example of the farming LCA. So the main input of the farming LCA are fertilizer and chemical applied to the field, and also energy consumed during the farm, the practice and management, and the crop yield. And main output of the farming LCA are obviously the GHG emission associated with the main input. For example, chemical and fertilizer application rate are used to calculate so-called upstream GHG emissions in manufacturing fertilizer and chemicals. And then on-field or soil-related emission. Importantly, the nitrogen fertilizer use contributes a significant portion of the soil-related emissions. So when synthetic nitrogen fertilizer are applied for the crop production, a portion of the applied nitrogen fertilizer is directly converted to the N2O through soil microbial processes and released into the atmosphere. Furthermore, there is indirect N2O emissions associated with the volatilization of the fertilizer and the leaching and runoff of nitrate. So this is the main reason that the soil N2 emissions are responsible for the 50% of the agricultural GHG emissions. And another main input, such as on-farm energy consumption, is used to calculate again the upstream GHG emission from the producing each energy source, including the diesel and gasoline and the natural gas, LPG and the electricity, and then on-farm emission of the combusting, especially the diesel fuel during the farming. And finally, the crop yield is used to calculate the GHG intensity per kilogram or pound of the crop produces, which is called the functional unit of the farming LCA.
Sure. So obviously, these LCAs can be done at a variety of scales. I mean, you could potentially do one for your own farm. You could do one for all of the farms in Wisconsin or Canada or, whatever. So how are you, for this research project, let me maybe narrow it down. Like, how are you, first of all, what was the specific region of study that you were kind of narrowed in on? And then how were you getting these values? Were you just using models to predict things? Were you taking past data and, using that as a baseline? Were you out in the field collecting measurements? Where is this information coming from that is being put in and out of your LCA?
Yeah, sure. So typically the farming LCA conducted for the national scale evaluation to provide the national level or the reference carbon intensity of the farming to biofuel LCA. So thus our center mainly used the national level input data. So for example, our center's LCA has used the USDA farm survey data aggregated at the US state level to conduct the farming LCA at the national level, which has been implemented in our center's corn and soybean-based biofuel LCA. However, there has been growing interest in the creating the regional or the farm level evaluation to explore and address the geographic differences in farming. So we also use the farm level data for several our article we published to show the variation of the GHG emissions associated with the different farming practice at the farm level.
Okay, so you've got this kind of national level LCA that you're looking at. So then what do you do with the LCA? I mean, is the goal to kind of just give you a baseline? Is it to give you a baseline model that you can then create other models and kind of see the impacts of changing X or Y component? Is it just a rough estimate to identify main sources and then we kind of go from there? How is the LCA used after it's completed?
Yeah, thank you for the great question. So in my opinion, the LCA can serve the different way. For example, in our study, we conducted the corn farming LCA for the various practice and evaluate the potential impact and overall GHG emission compared to the national level result of the corn farming, so that the LCA result can guide the development of the GHG mitigation strategies. That is one purpose. But in the LCA, we often make a lot of the assumption, especially on certain values, such as the soil-related emission. We made a certain assumption, and then based on those assumptions, we calculate the soil-related emission. But however, that specific the component can be further refined with specific model. For example, the process-based agroecosystem model can provide more accurate the estimate based on the different soil condition and then climate condition. And also the field observation can be also used to provide those information so that more specific as a result can be provided to the users.
Hi everyone, I hope you're enjoying the show. Interested in learning more? Hoyoung's paper, Greenhouse Gas Mitigation Strategies and Opportunities for Agriculture, published in Agronomy Journal, is always freely available. If you are a certified crop advisor or certified professional soil scientist, you can take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Thanks again also to our sponsors, Meter Group and Gasmet Technologies. Meter specializes in robust soil moisture sensing, innovative weather monitoring, cloud data logging, advanced data visualization software, and more. Their well-published scientific instrumentation is used worldwide in universities, research and testing labs, government agencies, agriculture, and industrial applications. Listen to their new podcast, We Measure the World, to hear how innovative researchers leverage environmental data to make our world a better and more sustainable place at metergroup.com/fieldlabearth. For Gasmet Technologies, the GT5000 Terra is a robust and portable multi-gas analyzer for fieldwork weighing 20.7 pounds. The GT5000 Terra is splash-proof IP54 rated with an internal pump and battery and instantaneous readings of up to 50 gases at sub-ppm concentrations. Check out the quick setup guide and learn more about Gasmet Technologies at www.gasmet.com and the links in the show notes. Thank you for being our sponsor. Let's get back to the show. Okay, so it's a little bit of both, where you can use it as a baseline and also to inform these strategies. I like that. I like that a lot. I find this research really interesting just to see like the scope, you know, like how big you can make it and how small, and like what factors to include. You know, do you include weather? Do you include heat? You know, like what all are you? I mean, obviously, that's not like an input of nitrogen if it's just like windy or whatever. But I just think this whole thing is really interesting. So moving on, though, we have talked about kind of the high-level LCA of how you were identifying some of these major inputs and outputs for these crop and livestock systems. So I'd like to then move on into how some of the mitigation strategies that your team identified for how we could potentially reduce those kind of high emission or factors.
Sure. So we, as you just briefly mentioned, we identified several mitigation, the practice and technology in our paper. Those technology address the main input of the farming LCA I just explained. So the first example is the precision agriculture, which is very one of the important practice to be considered. So the precision agriculture is the management, the plan that gather and the process and analyze different temporal and the spatial data, and then combine those data with other information to improve the resource use efficiency, such as the fertilizer and the fuel, and then improve the productivity and the profitability and then sustainability of the agricultural production. So currently there is the three common the precision agriculture technology adopted in the U.S. farm, which are the variable rate input application and the auto steerers tractor guidance system using GPS and GPS soil and the yield mapping. So these practices are effective to lower the on-farm fuel consumption, to optimize the fertilizer and chemical use, which further leads to the reduced soil and to emissions. And also the innovation are occurring upstream, such as the manufacturing, fertilizer, and chemical production stage by utilizing more renewable energy, both as the raw materials and energy sources. For example, ammonia, which is as the building block for all other nitrogen fertilizer, can be produced from the water, air, and then renewable electricity generated by the solar or the wind. And the farming energy fuel consumption can also reduce with conservation or the no-till the practice, which is very well-known the factor. I talk about the GHG reduction from the different farming practice and technology, but I also want to address the soil carbon sequestration promoted by either increasing crop residue carbon input to soil or the reducing carbon losses from the soil. For example, conversion tillage is well known to not only to lower the on-farm fuel consumption I just mentioned, but also enhance the soil carbon sequestration, resulting in synergetic reduction in the GHG emission. And in some area, the conservation tillage combined with the crop rotation with the cover crop has been identified to benefit soil carbon sequestration. Also, the livestock manure applied to soil can sequester the carbon in the soil. Finally, some of the emerging technology are being developed, such as cultivating the deep rooting crop varieties to sequester the more carbon in the root biomass.
Sure. Yeah, those all sound like some great strategies. So, obviously, though, it's not like a farmer can just go out today and completely change everything that they do on their farm. That's a little unrealistic. So, there are a lot of opportunities and also some obstacles to implement these. So, can you just talk a little bit about what it takes to actually start shifting farms to these practices, maybe some of the hurdles that they might have to leap, or some really good opportunities for them to start implementing that? Can you talk about that?
Sure. So main kind of the issue is the lack of the clear financial incentive to provide the farmers who perceive the risk of the changing farming practice. I think that is the most important issue. Currently, the USDA, the Natural Resource Conservation Service, run the several conservation programs that provide actually technical and then financial assistance to the farmer who plant and implement conservation practice, which is a really good program. But unfortunately, such programs have been underfunded and oversubscribed. As a result, the less than half of all applicants receiving funding. Fortunately, the recent Inflation Reduction Act, IRA, will provide nearly $20 billion in funding for the USDA's 4 conservation programs and technical assistance program that were last authorized in the 2018 the Farm Bill. With the additional investment, more producers will accessible to the conservation program, which leads to the lower GHG emissions from the agriculture sector, I expected. On the other hand, an incentive mechanism for the feedstock producer and supplier for the biofuel through biofuel regulation is being discussed. For example, the California Air Resources for the Low Carbon Fuel Standard, LCFS, currently incentivize the low carbon fuel production pathway from the specific individual biorefineries, but does not currently provide for certification of the low carbon intensity corn grain as biofuel feedstock, but assigned national level or reference level carbon intensity of the corn grain. So as a result, LCFS does not incentivize the corn producers who are willing to adopt sustainable carbon reducing practices. So if some of the issue around those technical detail we elaborate on our article are resolved. This would be great financial opportunity that the farmer can consider.
Sure. Yeah, obviously a lot there to factor in when making those farming decisions and trying to help them get there. So I think that leads pretty well then into our next question, which is about future research. Obviously, as the LCA itself continues to grow and be updated over time, I'm sure there will be some research opportunities there, but what else can we look ahead to in mitigating greenhouse gases in ag?
Sure. So the farming, as I explained, has mainly provided the GHG emission or the carbon intensity per the kilogram or the pound of the harvested crop for farming LCA. But as the agriculture increasingly become the supply of the multiple products, such as food, energy, and feed, there is growing interest from the landscape perspective. In other words, the LCA aims to calculate GHG emissions per area of the land. The landscape perspective would enable integrated the land management strategy for addressing multi-products from the land. Another future direction is to extend the agriculture or farming LCA framework to consider the impacts of the farming activities on providing the ecosystem services. Some of the ecosystem service that is particularly important to the agricultural activities include the air quality effect and the water quality and the quantity effect.
Yeah, sounds like a lot of good future research there. I have 3 questions left for you today. So the first question is, if people want to learn more about any of the things that we talked about today, obviously there's your lovely review paper, but where else can they go to learn more information?
Yeah, sure. So our center has developed the full life cycle analysis model, the GRID model, which account for the cradle to grave impact of diverse the vehicle technology and transportation fuels, energy system and material and chemical and agricultural farming practices. Furthermore, recently we also developed the feedstock carbon intensity calculator, which is an easy to use tool to calculate the farm level carbon intensity of the biofuel feedstock, including the corn and soybean. So you can find more information on our GRID website. Also, the US EPA published the annual report that provide the overview of the total GHG emission from the all economic sector in the United States. So you can find the information from the US EPA the website. Also, USDA ERS Economic Research Service has some of the website to provide information on the agricultural research on the climate change. Also, that is, I think, that is very good information you can find. Finally, there is about a lot of the information on agriculture related the provision in the IRA. So you can search some of the USDA website and then university website to find more detailed information on that.
All right. We will include links to as many of those as we can in our show notes. So then the next question is, how can people take the next step and be more involved with this kind of research or these kinds of important issues?
Yeah, I mean, obviously it is best way to try to keep up with is the latest information on agriculture-related research and use. I think this is the way to join some of the webinar and conference and online lecture related to the agricultural issue. I think that is the best way you can get involved in.
Sure. And then what is one fun fact that people wouldn't know about you if all they had was your research?
Sure. So I spent a lot of time to think about it, and I'm not sure if the listeners are familiar with the MBTI personality type test.
Mm-hmm.
Basically the test identified your personality from the extensive the profile of the 16 personality types. So the test has been a while, but I haven't tried the test till the last month. So when I finally did last month, my personality was identified as ISFJ. That is given the nickname the protector or defender for the good reason. On the other hand, I also found one website had a funny side of each type. So that site says that ISFJ tends to reflect on their past experience a lot. Unfortunately, for the many of those past experience tend to bubble up when they are trying to relax and have a good time. So I think I found this is so true to me. So if you want to find the true identity, maybe you can try the test.
Sure. My best friend is an ISFJ, so.
Oh, okay.
Yeah, and I'm an INFJ, so any MBTI people out there can now start to analyze away.
Okay.
Well, this has been so great to have you on the show. What a great fun fact with a nice backstory on it, and it feels so well researched. I like that a lot. Thank you so much for the obviously extremely important work that you are doing to improve agriculture, make it better for our planet, and the people that benefit from it with biofuels and food and all the other the fuel and fiber and all those things. So thank you so much for being on our show today.
Thank you so much.
Hi, everyone, and welcome to our Student Spotlight, where we highlight the work of graduate and undergraduate society student members. Today we'll be talking to Jeff. Welcome to the show. Can you start us off by introducing yourself and where you're studying?
Hi, Abby. Yeah, thanks for having me. My name is Jeffrey Cook, and I am at the University of California, Davis in a doctoral program in soil science and biogeochemistry.
Wonderful. And what are you currently researching?
So I have a few projects. My first project that I'm wrapping up and getting ready to publish had to do with tillage and cover cropping practices, in addition to composting practices and how those affect greenhouse gas emissions and soil carbon sequestration in the Central Valley of California.
Great. And if you could have your dream research project, what would that look like?
That's a really great question. I mean, I think that my dream research project would be a project where I could have a really positive impact on a farmer's financial situation, or really do something that could really impact policy in some way, in some positive way.
Awesome. Well, if anyone would like to get in touch with Jeff about his work, we'll have his contact information in our show notes. Thank you so much for being on the show today, and best wishes on your future studies and career. Thank you.
Thanks so much, Abby.
Thank you for listening to Field Lab Earth. More information can be found in the description below. Thank you.